I spent my first 25 years with Microsoft and I learned so much, which triggered the idea that maybe we should give back. So we're gonna have a podcast. My name is Mark Souza. I'm the Chief Technology Officer for Microsoft Asia region. Now I'm going to be joined by many guests from different companies, and together we're going to share what we learned. We're going to talk about technology, challenges, and solutions. So please join us. Hello, and welcome to the next episode of Let's Talk Tech. Today we're going to demystify what SLMs and what SLMs can do for you. So we have a special guest, John Downs, a lifelong developer and a chief architect for Gen AI, to join us and help us demystify SLMs. John, welcome.
Thank you, Matt. Great to be here.
And thanks you for joining us. So let's jump in and get started. First of all, describe what is SLM?
Yeah, so when we think about the kinds of language models, right, OpenAI's GPT-4 model, GPT 3.5, Gemini, Anthropic models, all of those kinds of models that we typically think about, they really require very large amounts of hardware, right? They require cloud level data centers with GPUs, very, very fancy, expensive GPUs, lots of hardware, right? They're still kind of where the frontier research is going on, but there's this new category now that's coming in on the kind of the other side, which is small language models. So these are language models that don't require the same level of sophisticated hardware, the same level of GPUs, and they can, in some cases, can even run on something like your phone.
So almost sounds too good to be true. I can do almost the same thing for lower cost. So what are some of the things SLMs can do and can't do?
So I'll talk about four benefits of SLMs, and then I'll talk about some of the trade-offs that you have to make as well. So first one is, like I mentioned, these are really don't require the same level of hardware. Right, so they're much cheaper to run. They're also a lot more carbon efficient because you don't have to run in these kinds of facilities with that level of power. The second benefit is that they tend to be a lot faster. Because they're so much smaller, the amount of time it takes for them to process a request to be able to generate tokens is much quicker as well. The third benefit is they run offline, so you don't need to have an internet connection to be able to access them. And the fourth is that you can use them to process very large numbers of requests. With an SLM, if they're running locally on your device, then it's a lot cheaper to be able to do that, and you can get through a lot more requests. But as you mentioned, there are places where they're not quite as good as LLMs, and there's a reason why we still have both. So one reason is they just have less knowledge, right? So the way that these language models work is they have things called parameters. This is essentially the unit of how the model works. A small language model only really has maybe a few 100 million to a few billion parameters. And the fact that they are smaller, of course, gives us those benefits we just spoke about, but it also means there's less room for them to learn information. So they don't perform as well with general knowledge, with specialized knowledge, with those kinds of things. There's also some places where they're less accurate as well. So for certain kinds of tasks, SLMs just don't do quite as good a job. And then the third kind of trade-off, I guess, you're making is when it comes to things like being able to either create very creative outputs, or where you want to be able to shift between tasks rapidly and have lots of different capabilities, they're not as powerful as those high-end models. And typically the way that SLMs work is they have to be fine-tuned for specific tasks. So you figure out a particular task that you want it to do, you really fine-tune it to do that one task. So there's some trade-offs there.
And I assume, obviously, that a fine-tuning of a SLM is faster and much lower cost than an LLM.
It is. Yeah,
Excellent.
Absolutely it is compared to an LLM. Yes,
definitely. So why don't give us a couple of use cases?
One of the ones I mentioned before was disconnected scenarios, right? This is places where you don't have internet connectivity. And so we have actually been working with some use cases around using SLMs on farms. So in places where there might not be any network connectivity, but farmers might need to be able to access information about, for example, the manuals for all of their farm appliances. And so Microsoft Research has actually been working on this exact use case, being able to run essentially a retrieval augmented generation pipeline on a consumer kind of grade laptop and have that available offline with no internet connectivity. So that's pretty powerful. A second is in scenarios where you might not want data to be leaving a device or going to the cloud. So for example, you can imagine if you've got a device where a user's storing their health information, they might not be comfortable with sending that data to a cloud service. by using an SLM, you can allow them to interact with that data using everything on the device. And so that's a really good way to preserve user privacy. There's also a set of, I guess, text processing kind of tasks as well. So things like text classification or analyze the sentiment of some text. So understanding if it's positive or negative tone, for example, or being able to summarize text in some cases as well. The fourth use case I want to talk about is multimodal pipelines. So this is a kind of architecture that we're seeing emerge a lot at the moment. These kinds of architectures are kind of the Copilot-like scenarios where applications will expose an AI interface that is very capable of doing lots of different kinds of tasks. And typically the way that we're seeing that these start to get built is something akin to what I've got on this diagram here. So the way this might work is a user sends a query. So this is the thing that they're trying to achieve. And the first thing that happens is the application performs what we call intent detection. So this is trying to understand what is the user trying to achieve here, and then mapping that to one of a series of understood capabilities that this application can do. And then each of those capabilities might be implemented a bit differently. And if we look at an example of this, let's say that we're building a AI assistant for teachers in a classroom. So the kinds of things that we might do for that would be, for example, creating assessments, right? So the teacher wants to be able to create a quiz. And in that case, the process by which that might work would be the application would need to first request a bunch of quiz questions, which requires some knowledge about that topic area. Then it needs to validate the questions and answers are correct, and then it would actually provide those back to the teacher. Or if we look at a completely different example use case within the same application, finding lesson resources, right? So imagine the school has a database, a library of lesson materials that teachers can draw upon. So we might want to do effectively a RAG kind of scenario here, right, where we have that data stored in a database that we can access through a vector store with embeddings. And before we even do that, we might want to clean up the user's query a bit and make sure that it's a valid query and it's going to have the best chance of success when it's turned into an embedding. So we've got these kinds of different pieces along the way, and you can imagine lots and lots of other kinds of scenarios here. Now, each of those purple boxes that we can see on this slide corresponds to a call to a language model of some form, but they don't all have to be large language models. So in this case, we could actually use small language models for some of these tasks here, especially the tasks that are a little bit more constrained and kind of well understood and that are a bit simpler. They still require a language model, but they don't require the power of a full large language model. And so, for example, intent detection is a really good example of the kind of text classification that I mentioned earlier. Query rewriting is effectively a summarizing kind of approach as well. And both of these are potentially really good fits for small language models. But then you can use large language models for those other components that might require more kind of complex capabilities or more knowledge that isn't available on the SLM.
This is pretty cool. In past episodes, we actually introduced hybrid, the ability of taking two large language models into the same solution. And what I'm looking at here looks like a mixed model solution for teachers in this case. Is that correct?
Absolutely. And you could imagine you could have different SLMs or different fine-tuned versions of the same base SLM here. You could be using multiple different LLMs to do each of these components as well. And so if we look, for example, at Microsoft Semantic Kernel or other systems that do orchestration of these kinds of complex applications, it's actually pretty straightforward to say, for this particular kind of task, send it to this kind of model, and here's where it's hosted, and here's how you get access to it. So it's getting easier and easier to create these kinds of hybrid or multi-model solutions. Yeah.
Excellent. And you have to make that decision. I mean, it all could be done with one large language model, but if you have a smaller device that you want to run it offline or lower cost, you would choose SLM for some of these modules.
Absolutely, yeah. You can reserve the LLM calls for the things that really need it, and then use the SLMs where they make sense as well.
Excellent. You have any examples you want to show us?
I do, yeah. So I'm going to show a little demo of running the Phi model. So we actually, just in the last few days, we announced Phi 3, which is Microsoft's series of small language models. And I'm going to actually run this on my local laptop. So I'm using this third-party application. It's called LM Studio. And this allows me to download and then run different small language models right on my machine. And I could do this without any internet connectivity or networking of any kind. So in this case, I'm going to use this particular version. This is Phi 3 Mini, and this particular version of it is 7.6 gigabytes. So that's well within the 32 gigs of memory that I have on my laptop. I'm actually going to implement the intent detection kind of component that I showed on that diagram, right? So in this case, imagine that I'm a teacher. Effectively, the job of this particular component, this particular request, is to take this query and then to figure out which of those intents the user has asked for. So in this case, the query is, I'm teaching a class tomorrow about basic science concepts for 6-year-olds. Give me 3 simple multiple choice quiz questions and answers. So in this case, I don't want the actual quiz questions and answers, right? All I want to know is which of those paths should I go down based on this query. And so if I was to execute this, there we go. It's come back with create assessments, which is one of the categories I put in the prompt. Now, in this case, it's also still kind of rabbiting on. I'm going to stop it. There's various tweaks you can do to kind of improve the behavior here. One of them is fine tuning, as I mentioned. So that's still an important component of how you build these. But you can see here, it's given what is essentially the correct answer. It was pretty fast as well. It came back with 4.13 tokens per second, which is pretty good. And actually, let's have a look at another example. So in this case, now I actually want to say, well, let's try and see how it works if we actually ask it to create those quiz questions, right? So this requires a bit more creativity in terms of creating new quiz questions. It also requires understanding of basic science concepts and understanding what a 6-year-old would understand about basic science concepts. So if I was to execute this against the Phi model, you can see it starts to come back with real answers. And it has worded it in such a way that it's targeted to 6-year-olds. So it says salt is like that, it's in our snacks. What happens when you mix it, right? And it gives us the questions and the answers there. And it's still going. You can see it's actually pretty fast, right? And again, this is just running on my laptop. If you were running this on a more powerful computer, it would perform even better. And you can see here that the information that it's giving, the answers that it's given, are actually pretty good. And this is one of the interesting things about the Phi models, right? So I think what we're seeing now is, because this is such an active area of research, the Phi models in particular are actually really good at certain kinds of problems. And in actual fact, this kind of question might actually be a really good fit for Phi in the future.
That's awesome. So just to reiterate, your first prompt you ran was intent detection, and it came back very, very quickly. And then all of a sudden the teacher ran a prompt, and actually the result came back also very, very quickly with a model that's less than 8 gigabytes on your laptop.
That's right.
These are really good examples. What's next for SLM?
Yeah, well, as you can see, really, this is an area of very active research, and a lot of people are working on SLMs in various forms. So, Microsoft is actively building out the Phi models. There'll be more released in the near future, and benchmarking them and understanding where they do and don't fit, and we keep tweaking them and trying to make them better and better. There's also a lot of work going on in figuring out their use cases. But I think in terms of what this all means, we're really getting to the point now where we've got this whole set of models and set of capabilities with all of these different trade-offs and characteristics. And so it's going to become increasingly important to mix models together in interesting ways. And SLMs are a really good way of being able to achieve a very cost-efficient kind of architecture, but of course at the cost of certain types of accuracy or other performance we mentioned. If I was somebody watching, I would really want to try this out myself. The Phi 3, as I mentioned, has just been released. So you can go to aka.ms/try-Phi 3. That will take you to the Azure AI Studio playground, where you can actually try Phi 3 directly. You can also download it and run it on your own machine, just like I did, or on an iPhone or another device. And you can do that by getting the models from Hugging Face.
And Hugging Face is just an input into AI Studio. They can just start with AI Studio if they want to.
Yeah, and AI Studio has, like I said, it has Phi available right now, Phi 3. You can also use it to do fine tuning.
Great. Well, John, thank you for helping demystify SLMs for us today and helping us with the do's and don'ts and some clarification. And we'd love to invite you back in future episodes to talk about this a little bit more as you advance your learnings.
Fantastic. Thanks, Mark. That'd be great.
And thank you to all of you for joining this episode of Let's Talk Tech, and we'll see you next time.